Vikings, Egyptians and Romans, what do they all have in common? Like us, they used boats to explore the world, find new places to live and exciting foods to eat. But technology has allowed boats to become bigger and better. They are faster, they can carry more and look cooler. Well, maybe not cooler, but the way boats float remains the same. To float, they need to weigh the same or less than the amount of water they displace. But what does that even mean? To demonstrate, let's reenact an experiment believed to have been carried out more than 2,000 years ago by the scientist Archimedes. I filled a bath with hopefully warm water and I've marked the level of the water. Let's see what happens when I climb in. Whoa! Oh, that's colder than I thought it would be. But look what's happened to the level of the water. It's risen. That's because the water has had to move to make space for the parts of my body that are now in it. The volume or amount of space my body takes up is the same as the volume of water that's had to move. And we call this displacement. Let's dry off and chat some more. When an object like a boat is in water, there are two important forces acting on it. Gravity is pulling it downwards. Gravity is the force that pulls everything down towards the centre of the earth. So gravity pulls everything down to the bottom of the ocean, right? Well, no. Think about cargo ships. These are huge boats that are made of metal, filled with heavy things like cars and containers full of food, but they still float. That's because there's another force called buoyancy that pushes our boat upwards in water. You can actually feel this force if you try and push an empty bottle underwater. The buoyancy fights against you. It's a bit like a tug of war, with gravity pulling downwards and buoyancy pushing upwards. And the size of this upwards force is the same as the weight of water that the boat displaces or moves, just like the water I displaced when I sat in the bath. So, if we want our boat to float, we need to make sure it can displace enough water so that the amount of buoyancy force pushing upwards is the same as the amount of gravity pulling downwards. Otherwise, there will be too much downwards force and our boat will sink. So, what determines how much water a boat can displace? It's not just to do with its weight, but also its shape. To demonstrate, we'll need a bowl of water and some modelling clay. If I drop this ball of clay into the water, it sinks. But if I take the same ball of clay and shape it into a really simple boat, it floats. Everything in our world has what we call density, which just means how much stuff or mass is packed into the space that an object takes up. When we change the shape of our clay into a boat, it still weighs the same, but it takes up more space, which we call volume. When we look at the calculation for density, density equals mass over volume, we can see that if we increase an object's volume, we decrease its density. If the density of a boat is less than the density of water, then it floats, because it can displace enough water so the buoyancy force pushing upwards is the same as the gravity pulling down. So, if we want to design a boat that floats, we want to give it a low density. And we can do this by making it weigh less or by increasing its underwater volume by changing its shape. Now that we've learned what makes our boats float, I think we'd better get experimenting ourselves. I'm going to challenge my friend Ross to see who can design a boat that can hold the most weight possible. So why don't you join in at home? Hi Ross, so do you think you're up for the challenge?
Oh, definitely Claire, I'm going to smash this!
Awesome, and you're only going to need a few supplies to get started. First, we're going to need our very own ship testing tank, just like real engineers use to test models of boats before they get built. You could use a bowl of water, a sink, or even a bath. We'll also need some supplies to build our boat.
I've got some recycling lying around, would that work?
Absolutely! Recycled cardboard or plastic would be perfect for this. Basically whatever you've got in the house. You might also want some tape and some scissors. Last, we're going to need some weights to test our boats. You could use stones, coins, or even spoons.
I have got loads of spoons just lying around, so let's use those.
Perfect! Right, we better go and get started, Ross. I'll catch up in a bit and see whose design can hold the most weight. Why don't you join in at home? See what happens when you build a really small, narrow boat or a huge, wide one. You could try and put all the weight in the middle or all to one side of your boat.
Eureka!
How did you get on?
Oh, that was much trickier than I expected, but I managed to get 15 spoons made up of teaspoons and tablespoons.
What? That is amazing! I only managed 8 spoons. That's great. What do you think you did that worked so well?
I think my design worked well after a lot of trial and error at first. I eventually took some inspiration from the design of a raft and used empty cans with blue tack over the holes to seal in that air. This, along with a nice light cardboard middle, gave my boat low density and, most importantly, it allowed it to carry some extra weight without sinking.
Awesome! It sounds like you really engineered your boat well. Thanks for joining in the challenge. How did you get on at home? You can see from our attempts that it's also quite important to think about where you put the weights in your boat so it doesn't tip over. Why not challenge your friends and family to see what amazing boats they can come up with? Don't forget to send us photos of your designs and let us know if you manage to beat our record. See ya!